Hello everyone, welcome to Preparation with Harish. Today's topic is physical quantities. So, as you all know, in NEET or JEE, units and measurements chapter holds a good weightage, like one or two definite questions will be asked in every year NEET or a JEE. So, to understand units and measurements properly, you should know this basic concept, that is physical quantities. So today's class we shall see what are physical quantities. So physical quantities, please do like my video and please do subscribe, share, and please stay tuned for the similar videos of physics. Yes, let's start. So physical quantities. So as I said, physical quantities are nothing but a quantities which can be measurable. Okay, so first and foremost thing is it should be measurable, and second thing, it should explain the physical happenings in the nature. Whatever the physical happenings are happening in the nature, no, it should explain those physical happenings in the nature. And the third thing is it should follow all laws. Okay, so the easiest definition of physical quantities, or to understand physical quantities, is it should be measurable. Next, it should be able to explain various physical happenings in the nature. And the third one is it should obey all laws. Okay, so to be a physical quantity, it should be measurable, it should explain all physical happenings in the nature, and it should follow all laws. Okay, clear. So to explain physical quantities, there are various examples. So let us take one example. Length. Sorry, just a minute. Length. See, length is a physical quantity. You can say length as a physical quantity. Why? Because it is measurable. Yeah, you can measure the length either in meter, centimeter, millimeter, etc. Correct? Light years, parsec. Correct? No? So you can measure. Yes, it is measurable. It should be able to explain various physical happenings in the nature. Yes, it is explaining the physical happenings in the nature. Something is measuring, no, it is giving us something is this much bigger, this much longer. Correct, so it should be able to explain various physical happenings. Yeah, it is doing it. It should be obey all laws. Yes, it obeys all laws. Correct, no? So something which satisfy all these three conditions are considered as a physical quantities. Okay, sir. Then is sadness, happiness, all this called as physical quantities? No. Why? Because see, it should be able to explain various physical happenings. Yeah, in an environment, sadness is happening, happiness, yes, that is happening. So physical happenings, that is true, but it can't be measurable, no. Let's say if you text your crush and you don't get a reply, obviously you feel bad. No, I did not receive the message. अयो वापस मेरे को रिप्लाई नहीं किया यार, you go into depressions. But that pain can't be measurable, no. Imagine you scored A1, whether it be JEE mains or a NEET, how happy you feel, no. That happiness is, not measurable. Correct, no. So that is why these, you can say this as all the emotions, all emotions are not physical quantities. So all emotions are not physical quantities. Only the things which satisfy these three conditions are physical quantities. So let us see some properties of physical quantities. Before that, I'll leave you people, just pause the video and please do take down this. Okay, now let us see how physical quantities are represented. So representation of a physical quantity. Okay. See, physical quantities can be represented by two things. First one is by measuring. So, whenever you measure something, you get something in result, no? So, that is what is called magnitude. Or you can also say numerical value. Okay, and second thing is by unit. By giving a proper unit for it. So, a unit. So, can I say physical quantities is equals to magnitude into unit? Correct, no? Magnitude into unit, that is magnitude and unit. So I will represent physical quantities as q, magnitude as m, and unit as u, n, u. So a physical quantity can be represented by n into u, where n represents the magnitude and u represents the direction. Let us take a physical quantity, area. So there is a garden of 40 meters square area. So here area is equals to, for example, area is equals to 40 meters square. Here you can see 40 is the magnitude, correct? A numerical value. Meter square is the unit of area, correct? No? Similarly, I can say speed 10 meter per second, where 10 is the magnitude and meter per second is the unit, correct? No? So this is how we represent the physical quantity. This representation of physical quantity is very easy. A quantity is represented by its magnitude and a unit, correct? No? So there is one exception case here, that is oh, I'm so sorry. Please do pause the video and take down the notes. Okay. Prior to any of this. See, always remember whatever I said, no? Physical quantity is equals to nu, correct? Physical quantity is equals to magnitude into unit. This is always constant. Means what I am trying to say is nu is always constant. But how? See, let us take an example of length only. So length is equals to 10 meter, or the same length is equals to 10 centimeter or length is equals to 100 meter. See, whatever you do, you change the value of n or you change the value of u. Means you change the units or you change the length. Whatever you do here, the quantity will remain as a length only. Correct, no? So that is why the nu is always a constant. Always the value of nu is constant. So I hope you will remember this and please do take down this. Okay, so now we shall study the types of physical quantities. See, types of physical quantities. See, there are three types. One is ratio type, second one is scalars, and third one is vectors, and fourth one are tensors. See, ratio types are those quantities, physical quantities, which are having same units. Ratio of two similar physical quantities. It is a ratio of two similar physical quantities. For example, you can take strain. See, strain as we all know, it is a change in length upon original length. So stress is something which is change in length upon original length. It is a ratio of two similar quantities only, no? So the unit of change is meter only. Sorry, length is meter only, and original length is also meter only. So meter cancelled. There is no unit. Students get confused here. That is, one confusion is students think that if there is no unit, then it is not a physical quantity. No, that is wrong. So you see the definition. The definition of physical quantity says it should be measurable. Yeah, strain is measurable. It should explain physical happenings. Yes, it is explaining some length is changing, and that is explaining some physical happening. Then it should follow all laws, obey laws. Correct? Yes, it is obeying. No, it comes under Young's law, Hooke's law. Correct? No, stress upon strain is directly proportional to constant. Correct? No? So it is explaining laws as well. So that is why you should understand this. If there is no unit also, then you can say those quantities also are physical quantity. So similarly, I can give one more example. B, that is refractive index. Then which other quantities? You can say relative density. Correct? What is relative density? Density of object upon density of water. Okay, so I hope you understood this. For first type is ratio types. In ratio types, two similar physical quantities would be present and they will have no unit. So write down an important note here, that is note two similar physical quantities which are present in a ratio are dimensionless. that is has no unit. I hope you clear with this. Okay, please do remember this, and we will study what is dimension in the dimension topic. Okay, yes. So I hope you clear with the first type, that is ratio. Please to take down, pause the video and take down. Okay. See, I think your preparation will be going very well, I think. So please don't waste your time. अच्छे से पढ़ाई पे ध्यान दो. Utilize your time as much as you can. Don't see any motivational videos to get motivation. Get the motivation from yourself as well. Self motivation is greater than the motivation what you get in the YouTubes, I believe. So yeah, next type, that is scalar. I think you people know this, right? Scalars and vectors. So see, next type was scalars, physical quantities, and another type was vectors, physical quantities. And tensors I'll explain between these. See, scalars are those which has only magnitude. Only magnitude, that's it. No direction at all. Means the quantities which is having only magnitude, that's it. Direction से फर्क ही नहीं पड़ता. It doesn't matter with the direction. Example, length, heat. This is one best example. Also work. See, it doesn't matter. No, heat किधर से आया? Like from here. It doesn't matter. Wherever the work also. See, this you will study very well in the thermodynamics chapter. Let's say if you want to move from A to B point, work done through this, work done through here, or work done through here, all remain same only. It doesn't matter with the directions, however it may pass. So these type of quantities are called scalar quantities, and this we will study in detail in vectors chapter. Next type is vectors. See, vectors which has both magnitude and direction as well. Let us say for example velocity. Correct, no? Velocity 2 meter per second in towards east. Correct, no? So like this, you represent or you give direction as well. Those kind of called vectors. You know, some kind of quantities, no, which lies between both scalar and vector, they are called as tensor quantity. So the tensor quantities are those which lies between scalars and vectors. Like you can't, they will be having a directions, okay? So it is not that they don't have direction, these tensor quantities, but to give the direction of tensor quantities is difficult. You can't give. Like examples here, I will give you moment of inertia. You can't, it is having direction, but to give the direction of moment of inertia, difficult. Even current. See, current is having direction, but to say the direction of current is impossible. If I take a wire like this, if I bend a wire like this, it will pass like this. If I take a wire like this, it will pass like this. Correct, no? Direction is there for current, but to give the direction of current is not possible. So that kind of quantities are called tensor quantities. And yeah, so in the next video, we'll start with the units. We will study what all units are, and we will see what are fundamental units and what are derived units. And next we'll see dimensions, errors, and many more. Okay, I hope you people like this video. Please subscribe, and please stay tuned with me for your exams, competitive exams, for more such videos. And thank you so much. Please subscribe, please like the video, please share with your friends, and please keep supporting. Thank you all. Namaste.